suppose we have the equation that we obtained on the previous clip. Well, I'm not going to read it to you. There's the equation. Can we put this equation into the form x minus x naught squared plus y minus y naught? I've got the square in the wrong place there. Let's just kind of cross that out and put the square here and make sure we know that's a smudge. Okay, and z minus z naught squared equals r squared. In other words, the form in which we can easily read off the values of the coordinates of the center point, x naught, y naught, z naught, and the square of the radius, so that we can find the location and radius of this sphere. So, if we have this equation, we can accomplish this. Let's just start by looking at x squared minus 4x. Now, that's part of x minus x naught squared. If you watch what we did before, we see that the negative 4x came from squaring the x minus 2 expression. Okay, now we got x squared minus 4x. The question is, what do we add to this in order to get a perfect square? Well, we know that x minus a quantity squared is x squared minus 2ax plus a squared. And if we look at this minus 4x and compare that with a minus 2ax, we see that 2a is going to have to equal 4, so that a is going to have to equal, well, half of 4. So let's see, 2a equals 4, so a equals 2. This means that if we add 4 to this expression, then we're going to have a perfect square, and that's going to help us get this form. Now, when we do this, of course, we can't just take x squared minus 4x and add 4 to it. We've changed the expression. But if we add 4 and then subtract 4, we see that we have a perfect square minus 4. We can do the same thing with y. We've got y squared minus 10y. Well, if 10 is your 2a for a y minus a squared, then that a is going to be 5, so this is going to be 25, and we'll put that in parentheses, but we'll subtract 25. And we can do the same with our z term. Don't have room to do this all in one line, but we're going to get z squared plus 8z plus 16 minus 16 plus 9 equals 0. Now, this equation is exactly the same as this equation. We've just changed the form of the equation. We've added numbers and subtracted them.